Example number 2. John is an avid sailor and dreams about competing in the Olympics. He wants to buy his own laser sailboat in 6 years, but in the meantime he sails on a friend's boat. The cost of a new laser is about $12,700, including taxes. John won $3,500 in his most recent race and can save $75 a month from his part-time job. So John uses $2,700 of the cash to buy a 6-year GIC that earns 5.25% compounded semi-annually, and he deposits his monthly savings of $75 into a high-interest savings account that earns 3.8% compounded monthly. Will the portfolio support the cost of a new laser in 6 years? B. If not, suggest a solution for John. So this one's a little bit easier because there are only 2 different things that we need to deal with. We need to deal with the GIC, and we need to deal with the savings account. So let's just first focus on that GIC. Now he only chose to invest $2,700 of the cash that he won from his prize. So we're going to say that the present value is negative $2,700. He's going to buy a 6-year GIC compounded semi-annually. So this is going to be 2. This guy is going to be 2, and n is going to be 6 times number of compounding periods per year, which is 2. The interest rate is 5.25%. There is no payments made to this. It's just one lump sum. And we're going to solve for the future value. So let's go back up here. Make this one work for us. So we're going to have 12. This is going to be 5.25. This one's going to be negative $2,700. The payment is going to be 0. Future value, we're going to come back to it. PY and CY are both 2. So the future value here is alpha, enter. 3684.70, so $3,684.70. Good. Well, that was easy. Let's talk about his deposits of $75 in a high-interest savings account. So we know that it's compounded monthly. So this is 12 and this is 12. And he's going to be doing this for 6 years. So a number of compounding periods per year times number of years. The interest rate is going to be 3.8%. The future value is 0, but we're making a $75 payment once a month. We're going to put a dot beside this future value because that's what we're going to be calculating. And let's calculate it. So this is going to be 12 times 6. Look at that. Love that. 3.8% interest. Present value is 0. Payment is negative 75. Future value we're going to get to. And the number of payments per year and compounding periods per year is 12. So I'm going to go to alpha and then enter. And look at that. I have 6,054.46. So let's see. Will the portfolio support the cost of a new laser in 6 years? So let's figure out what we got. So from our GIC we have 3,684.70. We want to add that to 6,054.46. And that is a grand total of $97.39.16. So $9,739.16. That is way lower than the $12,700 that we want. So no, it does not support. Did you kind of have a hunch that maybe it wouldn't support it because you know that you have a B question there? You are smart kidlets. Good for you. So let's think about what else he could have done. Well, the obvious is he could have invested all of the money from his prize. He could also invest his money into something a little bit more aggressive, like a mutual fund, an aggressive mutual fund, or stocks. Though with high risk that stocks can have, comes high reward. But the risk should not be minimized. You can lose part of your principal on a stock, whereas if you're investing in a Canada Savings Bond, it's low risk, but you also earn low interest. So he could have invested in something more aggressive or more risky. That would potentially get him more money. It could potentially lose him money, but he potentially could make more money in the long run.